Oh, well, hello internet, and thank you for joining. We will wait a couple of more minutes for people to join us, and we'll get it started. Let me make sure you all can see this. All right, I think it's big and crispy. Sweet. All right, let's get into it. Super excited for today. So last time, I apologize. There was a lot of drop frames, so the stream was quite laggy, even though we were building like really exciting initial building blocks that we needed for our Notion backend. And I will take you into a quick recap of what we ended up doing last time, and we'll go from there. All right. So on last stream, we ended up looking into what's our definition of a document is. Then we moved on into defining some of the rules. And then we started looking into how the inode table in Linux works. And that was an important model that we used to model how our documents will be stored in memory. And yeah, that's enabled us for constant time lookup. So that was pretty cool thing that we looked into last time. And then I gave a more concrete example of how we're going to use this inode to point to documents. And then we talked about the create document criteria. So we put some questions, we put some rules, and we haven't yet implemented the rules, but we started the use case. We also looked into the segments of the document and how it will conceptually be structured. And last time I was telling you that for each document, it will have segments, but it's essentially a segments tree. And this tree is unbounded, meaning that you can have as many number of direct children. And we wanted to maintain order, so we said that the children will point to each other. But there's one important thing that I missed last time, and I will briefly mention it, and then we will see it much more in detail when we get back to it, right? So last time we talked about if the segments point to each other for maintaining order, that is still a linked list, which is good for manipulating at the edges essentially. But what happens if we want to change things in the middle? Now that will be O of n. So I was tinkering with it and I was like, well, if we add an auxiliary data structure, which is a map in this case, kind of similar to how the inode points to all the documents, we'll have a map for each document tree that knows how to get to the segments. So for each segments now in the linked list, you have direct access to it. And because you can go backwards and forward from that particular part, so you can end up doing constant time changes. Of course, you've sacrificed a bit more space, but at least computationally, it's much more efficient. So you're doing all these computations in constant time because of the map and the linked list, which is just pointers, but you added a bit extra space. However, if you're looking into the extra space from O of n notation, so technically it's just O of n because the map is a list of pointers, so the O of n is much bigger, so you just O of n, which is quite great. You've got constant time changes of all the segments inside your document, and at the same time the space isn't that much too big to the point that it's problematic. But we'll get back into the segment once we get to implement it. All right, so what's next then? Now we moved into this. Still all last time. I created a GitHub for the Notion backend, and we started implementing the create document. And we started off by having it all into the same directory without any isolation between the modules. And then we started refactoring a bit. One thing that we did is that we ended up writing our first unit test for the create service. And I talked about why I created a service and a repository very briefly, and I can go over them again if you have questions, but today I just want to lay down the agenda. We have to look into how we will actually save our created document onto the database, and we're using graph database neo4j, so we will have to take a bit of a detour to look into what are graph databases, how are they different than document databases, how are they different than SQL, and we'll look into Cypher query language. You are about to do some art because it's an ASCII art. It's pretty damn cool. So stay tuned. All right, so let's quickly go through the code for what we have, then we'll move into the database and we'll look into the amazing stuff. All right. I want to make sure that the stream is healthy and we have no drop rates. Okay, stats seems okay. Please let me know in the chat if it gets laggy at any point, because yeah, I want to make sure you guys are actually getting the most out of this. Okay, for the create document, we started off by creating an in-memory repository. And the idea here was simple. We wanted to avoid implementing the database completely before actually testing how we can save things. And we talked about the Inode table. So we had a mental model of how we're going to do that. And indeed, our in-memory repository implements that Inode structure. And of course, we'll extend it a bit more, because right now it's all bare bone. Okay. And we created a service. And the idea is that you need an exact contract, if you will, that specifies what this document service offer. And for us, we wanted a way to initialize the service and be able to call it. So the doc service can only be, we can only call the create document on it. Let's take it line by line, and then I can elaborate more into the service and the repository pattern that we did. So yeah, we created the in-memory repository. We initialized the document service with the in-memory repo here. I talked about this option configuration pattern where you can allow your user to configure how they want to configure your object, but also give them a preset callbacks that they can do to override specific parts without having to pass the entire bloated struct or object back into the function. And this works pretty neat because you only have to override certain things and don't have to worry about all the other properties, but at the same time, you don't want to remember the exact location of the argument list. And then we check for an error, and if we have an error, we exit. Then we defined how we want our document to look like. So we created the document set ID with this 1234, gave it a name, and the documents then, which is the nested documents on it, is nil. And that documents is just an array of IDs. We went through this, I think, a couple of times now. So if you're confused, let me know and I can discuss it. And then we started with actually calling the first use case that we have, which is the create document. And we passed the document that we want to create to it. Again, we check if there's an error. If there's an error, we exit and we fail the test. Moving on, we say to the repository, hey, did you happen to save this document with this ID? And if it's not, then we failed. So the test have failed. So the create document wasn't able to actually save it to the repository. But if it did, then we passed. I put a post into my Instagram saying if you think this is a good test or a bad test. Think about this for a few seconds. I mean, I wrote it, right? But it's a bad test. So why is it a bad test? It's because it's not really tasting. It's not really testing any behavior. It is just testing that the repository can save a document and you can retrieve it. That sounds like a test that I can do directly on the repository without having to go through the create document use case. So how can we make this a useful test? Well, we need to test more about the validation, right? What happens if I pass you a document with an empty string? Right now, we don't have any guardrails for that. And we don't have a test that specifies if this is even something that we should care about. And if we go look at the code, there's no function for it. So we need to start thinking of like, what is the behavior that we're testing? And when I learned that, it was like a mind-blowing thing to know, because you always test behavior. And that's another reason why we do external tests. So in Go, you have the package. If you're under the same package, things are accessible. If you're not under the same package, it's only the exported methods and properties on the struct will be the ones that are accessible. But when we're testing, you typically want to test with external tests because you're trying to validate that what you contracted with other services actually work. Okay, so one part that we'll do today is looking into how to make this test better, whether adding more tests or actually testing the main behavior. Great. So this was the implementation of the create document. So our document service, it expects a repository, and that's kind of, you can even infer that behavior from here, because in our test, you can easily see that we're passing in a repository. And by the way, try to write your test first. And this is not just to do TDD for the sake of TDD, but it's to explore how you want your API to look like. This is a really crucial thing because we have been moving away from the whiteboard, and this is not good. But if you're moving away from the whiteboard to like think about design, at least try to design it first somehow through the test and then implement and refactor and make it clean. Okay, what else do we have here? Yeah, so this is the option pattern that I was mentioning. You define a type and a function that takes a pointer to your struct, and you return an error. And we stopped here, which is the rules. Okay, so let's go implement the rules, get the test done, and we'll get into the Neo4j implementation. All right, I have my ID already here, so you all stop making fun of me for having it load every time, and we talk about Vim every single time. So yeah. All right, what are the rules? Well, we go back to Figma to double check what our rules are. A document, okay, so the name is optional, so don't care if you passed in a name or not, nothing to validate. And we have, it must have an ID or a root. Great, an ID. Yeah, actually it's right there. Document must have a root as a parent or a valid document ID. Let's implement that. Okay, so we will start off by creating a test that test just for the root, and another test that will test for the ID. Then we'll put it all together and see how this can go. This is a bit strange. I don't know if this was my... I just did an update for the for Golang, and now my variables look a bit different. So anyways, so be it. I hope this is visible enough. Actually, this is what I'm gonna do. I think like that sketchbook kind of thing looks better. And let me check on the stream to see if you guys can see it. Yeah, I think that should be hopefully fine. All right, so we'll do we want to test create document, but with root, actually with valid parent ID, and it will be t testing.t. Great. So we wrote our initial thing here. And as before, we'll create an in-memory repo. I can do new in-memory repo. I would honestly just name it repo, but in case you're joining in at any point, I want to make sure you can still read everything. And here we'll check if the error is not null. We failed the test. Okay, now we create the doc service. Service and an error. Service.new. And we pass service with repository and the in-memory repo. Great. Now, again, okay, now we have a doc service, but let's see, what is it complaining about? Oh yeah, this doesn't return an error. We're just creating a repo here. Great. So that should work now. And now the doc service create document, and we get an error. Create doc service. Create document, but we need to specify the document. And here's where we start implementing our test. So we want to make sure that we return an error, like a validation error, in case the ID is empty. So let's test for that, and then yeah, let's even write multiple tests, and then we will refactor it and make it look pretty. So right now we'll just say empty parent ID. I promise you, I'll clean it like how we cleaned the code last time. It looked like a mess, and now it looks much better. So all right, so we have a document. I want so here's a doc, and I will create document. Well, actually, new document, and I don't even remember what options does it really take. Yeah, we haven't really specified anyway, well, with document name, I guess. Yeah, it's because the name is optional. I kind of did it like this, but now I'm rethinking it, and we will decide as we go. So I'll just leave it as is, and maybe the test will get us a eureka moment. So here is our new document, right? If we get an error, Okay, so this document right here wouldn't actually do what we want it to do, because the new document would always give it back to us with an ID. What we want is imagining like we got a request with a document with an invalid ID. So here's what we're gonna do: document, and if we look, we have an ID 1234. Name doesn't matter, and there's the documents, which is nil. And here is the first thing that we run into. We're like, well, where is the parent ID coming from? Like, we're talking that it must have a valid parent ID, but we really are not getting that from the document. So now we're faced with a question. Are we changing the create document to include the parent ID as a parameter? Or is the document model expecting a parent ID? What do you think? Well, if you guess that passing the parameter to create document, then we're probably on the same page. The document model doesn't have to know about its parent. So one thing that is a common pitfall, according to the theory at least, is you always are pointing things in two directions will cause so much headaches. So what you want is for your model to be as simple as possible and as efficient, self-sufficient as possible. So there is no need for a document to know its parent. It's only the parent that needs to know the child. Yeah, don't translate that to human life. I'm just talking about code here. Just saying. All right. So now we can go back to the new document, and we have to change the signature of the create document. All right. So documents, new document. Excuse me. Okay. Here is the error. Wonderful. Now what? Now the create document should take a parent ID, and then it should take the document. So here, parent ID. Well, we said empty parent ID. So now if error is nil, p.fatal, we say fatal f. We say we wanted to get an error, but we received nil. So here you're inverting. So typically you're checking for the nils, meaning that you're checking for if error is not nil, meaning that there is an error that exists. But here it's a bit different. You're saying error is equal to nil, then something bad happened because I was expecting it to throw an error. Well, to return an error. And we already see here that it's complaining about the create document being passed an empty string. So it's time to fix it. So here we say parent ID, which is a string. Now that works, but of course that breaks our other test, right? So that wouldn't even compile. So what we're gonna do is we're gonna comment out this test for now, write our core tests, which is we're actually starting to test behavior, then we'll get back to it. Okay, so now we should run this test. and it will fail because we're returning a nil error because we're not doing validation. But let's see it in action. Hey, it failed. We wanted to get an error, but we received nil. Pretty bad. Okie dokes. Alright, so let's go and fix it. So for the validation here, I want to do a consistent pattern for validation across everything. I recently tried this pattern that I dabbled with and I kind of liked. So the way this pattern works is as follow. You say, I have a type called validator, which is a function that returns an error. And then what we can do is like, you can say, function validate parent ID that takes parent ID and it returns a validator. And here you go. So this closure right here allows you to pass whatever you want to pass for the validation. And then your validator function can have access to that, so you can do whatever checking you want to do. And based on that, you return an error. If you want, you can extend that to like a struct, like you can say success or fail. But I think an error is a good enough indication if something bad happened, and you can know the type of the error as well. So here we will say okay, there's one thing that's still missing though, is that this is a method on the document service, right? Because we need access to the repository, so we can either implement it as part of the document service, or a bit later when we get into implementing the repository as a singleton, what we can do is we will have a registry of repositories, and you can just say, hey, document repository, give me this. So now your validation is completely isolated from your use case implementation. Pretty cool. But for now, a function would do it. Okay, so how does that go? Well, we'll say ds.repository get document by ID, parent ID. You get a doc and you get an error. We don't really care about the doc. If error, not nil, return error. Otherwise, well, do we really need to do that? We just return the error. Wonderful. Now, if we run this, this would still fail. Okay, still failed. Why did it fail? Because first off, we didn't call the validator. But yeah, let's do it the whole red-green refactor. It's fine. So we'll do ds develop parent ID. So now we say an error if error is not nil, we'll return error. Otherwise, we save the document and we'll return null. Now, what's the matter here? So, validate parent ID would return a validator. So that's a function. Oh, yeah. Okay. So that works, my friends. That works. Now what? Now we run it and it wouldn't run. It wouldn't work properly. So, oh, well, it did. Then something is not working as we completely expected, or is it? So the validate here return nil, most likely. Otherwise, this wouldn't have passed. And when you're in a situation where you find yourself when you're in a situation where you find yourself that you know an error should have happened, but then your test pass, this means your test needs a bit more tweaking to make sure that you cover the cases that shouldn't pass. Okay, so for example here, we know fully well that this should return an error. But it did return an error. The thing is, what type of error? Well, let's figure that out right now. I want to see what error it did. Document with ID doesn't exist. Then guess what? Our implementation is correct. So why was I confused? Because if I do get document by ID for the in-memory repository, and we have a get document, I didn't think that we implemented this last time, this check, but since we have the check, we implemented it, so it works. So it's working beautifully. Great. So now we are not accepting an empty parent ID. Now let's run this test. Again, I'll copy paste it a few times, but I promise you we'll refactor it. So now let's see if we pass root as a parent ID. What happens? So now create document with root. Now, if error is not nil, expected error to be nil, but and got error. And here with root as parent ID. All right, let's run this bad boy. Okay, so we're getting, oh, I don't like this format. Let's just delete the V and we can rerun to change the symbol. So we got document with ID, root doesn't exist. Okay, why doesn't it exist? Because we didn't really create the root document, and we said that when you're creating like once we create a user, they should have a root document, and that root document is not deleted by any means. That's the head of the tree that cannot be deleted. So what we need to do is that upon starting the repository, whenever we're initializing it, it should come with the root document being added to the list, and we should have validations to say that, hey, you can't delete the root document. Okay, then let's get to that. So here's our new in-memory repository, right? And this means that we have a document here. So a pointer to a document. The ID is root. It doesn't have a name. And it will be null. All right. Why are we complaining here? Because we just wanted a pointer to a document, right? This is a map. This is the inode table. So you have a root and off you go. This points to the root document. What are you complaining about? This is supposed to be the name. Oh, we need to add the label. Okie dokes, let's go to our test. Whoa, test passes. We have done a good job. But we still need really to add some protections against this inode table map. I'm honestly thinking that we can make it private, but I'm wondering if there's any implications of that. I don't really see one. So here we go. We'll make this a private table. Let's go run our tests. That runs fine. That runs fine. Go test HV. Yeah, so all our tests have been running fine. That's good. I also increased the size in the terminal so you can see it. Now what? So we have our get document, save document, the new repo returns it with the root document being created in the inode. Okay, so this right here is done. We will talk a bit later about DTOs, but I want to get into the graph first and how we're going to model this, what we have right here, into the database and how we're going to communicate it back and forth. So also here we should return the error, or I can just save it and return it just like that. Also, there is another technique that I want to talk about a bit later, but I'll give you a brief glimpse. A lot of the times you want to do multiple validation. It's not just a single validation that you want to do. And what will end up happening is that you'll create like a validation pipeline. So you say, hey, here's all the things that I want you to validate, go validate them. And this is where the validator pattern here, I don't know, this is not a true pattern. Like, this is something that I've done and I liked. But the validator will go and you'd run every validator, and having that as a type works really well. Okay, now what? Now we have our create document implemented, but the tests are not done. We have one more test, then we have to refactor. Well, at least I think it's one more. Maybe we'll find a bit more. So now we want to test. So we tested without without a parent ID, with the root as the parent ID. We also have the third case, which is passing a valid parent ID or an invalid parent ID. So two more. So we say now with invalid parent ID, right? And this is honestly very similar to the empty one because just wouldn't find it, so that's fine. Let's now test with the valid parent ID. So how can we test that? So we need to create a document that have child documents, and we can see if the inode table is able to traverse that or not, which we haven't really implemented this behavior in the repository yet, which will let us implement it. And that's how you do like iterative implementation when you're driven by tests. So all right, let's create a document. So here is our new document that we created in all of these tests, and we're passing it to the root, but we want to pass another one. Sorry, give me a second. In the create document here, we're saving this to the root. So if we go to the save, we're saying here, take this ID and save it. Okay, so actually what we can do is that we can point root to a null pointer, since the root, well, no, the root is a document. Okay, here's what's happening. Here's what's going on in my brain that is not proper. So in the create document, you're passing a parent ID, and we're saying, hey, root, we want you to be the parent for our child document. And we were able to test that when you get root as a parent ID, it accepts it, but you haven't tested behavior yet. And what is that behavior? Is that the root now should have the doc ID as its child. So we first say if we get an error, it's nil, but now I want to, in memory repo, get document by ID, root, if my error is not nil, fatal error, otherwise root want document ID to exist. So I'm just gonna say want, not even, it's if the root document dot documents, we want to say, does it contain the document ID that we have provided? Okay, so let me check. All right, so what we can do is like we can do sort.search for So it takes an int and it takes a function. Let's see. So here you're using like sort and search to find, but oh, guess what? There's a find here. Yeah, but all of these would have to require like sorting first, and I honestly don't think it's worth it at all. So we can just say we can do it ourselves. So for root d in root documents or doc IDs or doc ID in range documents. Okay, now what if doc ID is equal to the doc ID? Then we say it's found. Great. And that's it. If it's not found, then we fail the test. All right, so, well, actually, I don't even need to do that. It's not that wide, but yeah. So here, if we run this test now, it should fail because the new document ID is not actually being added anywhere. We assume that it will, but it didn't. And that, my friends, are testing behavior. See? As a child of root, but found none. And a better thing to do is to actually give what we found. So rather than found none, you can say found root documents. So if that's the case, you can see here we didn't get any. So let's go and fix it. So we go to our repository, the create document. Right. So here you say the error when you save it, but this is handled by the save in the repository actually. So you can return this here and we say repository save document. So here you see how we're adding sorry, I'm trying to think how we can add this to the node, because save document only accepts a document. So we have a decision to make. Are we changing again the signature to save document, or what are we going to be doing here? So if we go in the create document, so we get a valid parent ID. So save document now could technically take parent ID and a document, and we have to fix that signature. So there's this approach Another approach would be repo, give me the parent, make the change it to it, and then you save that document back. But also we have to think of, so this is for nested documents will always add it to the parent. So we need the parent regardless. So no matter what you really do, need to operate on the parent side. So there is no need to get the parent, make change to it. Well, let me show you what I mean. If you get the parents, right, you'd say parent doc, you'd say repository, get document by ID, parent ID, error is not nil, you return the error, and now parent doc dot documents equal append parent doc dot documents, and you append the new doc dot ID. Then you have to save the parent doc. Are we missing something? Most likely yes. So let's have a look. Here, we're saying add this to the root. So this would work, and this would allow our test to pass. But then you get another issue, which is your inode table is not properly implemented, because now if you say get document by ID and you want to refer to this ID, it wouldn't actually exist. And best way to see it is to see it through the test. So here the test should pass, but let me demonstrate what I mean by that issue. So here we found it, right? But we still need to say in memrepo get document by ID. Now the doc that we created dot ID. I don't care for the existence of the document, I just care if there is an error. If error is not nil, you don't zero error. Now that same test, get document by ID, right? It's a string, and this is an ID data type. Okay, so now if I run the same test again, now it should fail. Right, document with the ID, the UID right here, doesn't exist. Right, so if we go back to the in-memory repo and we, to the create document, we check here that we're retrieving the parent document, adding to it, like we're appending the doc ID, but we're forgetting that our inode setup has to also include the node. So this is, let's say this is the root document. Root document has like 2 and 3, but 2 and 3 is accessible through the table directly as well. So what we can do is we can say, now that we saved the parent doc, okay, now what? We can say yes repository dot save document, and we pass the document, and that would make the test pass. Now we have to consider some things here. Let's first see the test pass, because green is always a happy path. Whoa, nice. So there is a lot going on in this test, but we have to first think of if this is the proper place to do it. Excuse me. All right. Now, this get document by ID, and then you're saving a document, and then you're saving another document. This is now you're getting into the distributed system territory, because you are retrieving, you're doing a read. So this has to do like you're going to an external system, doing a read, and then you're saying, okay, now I finished this read, save this read, right? Assuming that nothing have happened or no concurrent operations are running. And then you save that document. So for example, what happens if you read the document and you save the root document successfully, for example, but then you don't actually save the document? Well, now you are in an inconsistent state. So would it be better if the saved document is doing this operation as one unit, right? So I don't really want to get into transactions just yet, and I don't want to get into these concepts just yet. But because we're aware about them, because we're now bringing these issues up, we have to be a bit more critical about it. You cannot just like use external systems as if they are like your own code base. So, hey, get me a document by ID. Well, what's the cost involved, right? Whether it's performance, whether that you run into distributed system issues about like fallacies that might happen, errors that might happen. So don't have assumptions that everything works. Have assumptions that everything will fail. And this is the first lesson that we'll learn about in distributed systems, is that things will fail. And because this is not an atomic operation, and we can get more into what an atomic operation means, but ultimately it means like things run as a one unit. So it's either all pass or all fail. And here we haven't really done that. So what's our alternative? Well, what about if the saved document implementation handles that for us? So when we pass a saved document, we can pass it a parent ID, and it can handle saving that. So for example, if let's say we do that right here, then we say inode the table, and you get parent ID documents equal, let's say, parent documents. Parent documents, and you add the new doc.id. Now, so that's saved in terms of like for the parents. Now you added this new document and you return nil. So let me just show you that this will do the same exact thing here. But that would have other implications, of course, that you would have to change the signature of the interface, which you have to be very, very diligent when you're doing that. Right now, it doesn't matter because we're still in like early development phase, but you don't just like change the interface scarcely. You always have to be quite careful when you do that. Okay. Now what? I wanted to show you that it would work the same if we did this. So now if I go to the repository right here, and I can say parent ID, I'll type string. Now that should work. And now all what I can do is, rather than doing any of that, I'll comment it out because we might most likely, well, end up with that initial implementation. So we'll see. So parent ID doc. Now, if I run this, yeah, it passes. So these two options are valid options. Now let's think about it a bit more now. So the create document right now will pass its parent ID. So it handled the validation and then it said to the repository, hey, save this new document for me, and I don't care how that gets saved. I think this is a simpler model because we don't have to deal with distribution issues, because you're realistically getting the data. Well, if we go to the in-memory repo, right now it's local, but a bit later today we'll learn about Cypher and we might get a chance to implement it right now. But I'm thinking most likely you'll have to do a couple of queries anyways. So there is no really escaping from that distribution issue. Except that you can run it now into a transaction, right? So you can think of a transaction as something that either all succeeds together or all fails together. This is an extreme oversimplification, and I want to get much more into transactions, but I want that to be a stream of its own where we just talk about transactions. So yeah, the saved document in this situation will be a fairly safe operation, because you'll have one transaction that's kind of like saying, hey, get me the parent, whether that's the root or any other document, and you load that into your repository or your cache or your in-memory. You change the model a bit, so you're saying, hey, add this to my documents, and then it goes back and saves it, versus this code right here, which is in the create document. I will bring a guest next time that he was actually my mentor and I did take his course, and I think he will be amazing to answer this. But I'll bring him on to discuss what would be the ideal design in terms of like software design that we can do this on. I'm not gonna spoil who the guest is, but I'm sure you'll love it. So this is much more readable, right? If I do the create document and it's kind of like clear exactly what it does, like, hey, get me this document, you change this for me and do that, I think that reads better than saving the document. But I will opt in for the save document because of the transactions. And in our next stream, we will address this, and I'll actually note it down into my own Notion right here. Okay. All right, that's noted. Now, of course, similar concept needs to happen here for the is parent ID, is that when we pass a valid parent ID, we need to check that the parent ID actually got what it got. So rather than the root document here, it will be our parent ID. So let me just copy all of that and bam. Great, but this is no longer going to be the root. We need this to be the with valid parent ID. Well, oh yeah, we haven't really finished implementing that. Sorry guys, my bad. All right. So with valid parent ID, what do we do? It's again kind of similar, but here we would say, let's give it an arg. New document. So we created this document. So this is parent doc, child doc. Okay, so we created a parent and a child. I'm just gonna check the error once for either of these has an error. It will error out, so that's fine for now. Now we will, for the root, we'll add the parent doc, and now we need to add doc service doc. Doc service doc create document parent doc dot id child doc. We need to pass it as a string. Also, if this pattern is bothering us so much, we might just like changing to accepting the type ID. But I think when you're inside the repository or like going to the repository, things can get a bit more raw since you already validated it. So it should be fine. Now here's what we need to check. We need to check that the parent doc. So get the parent. And as a string. Parent document. Actually, this will be it is our parent, but I'm trying to find the good name that we can use here. Parent doc. Let's see now for parent doc, the documents, does it have the child doc? And here, parent documents. Document children, that would be a better name. No, that's not true because that's the actual parent document. So yeah, now let's run this and let's fix it up a bit because yeah, undefined doc. Yeah, we need to check that the child doc actually exists. All right, that passes. But of course, you don't want people to like open your file and essentially like see practically 3 tests that almost look identical. I think it was Martin Fowler, I think, that said if you have it like repeated 3 times, you have to refactor it. And it's time to refactor it. But I need a bit of coffee. Okay, so let's refactor this. This is how it looks like from far away from now. Not nice. What I'm gonna show you right now, I've got two different conflicting advice about it, right? There's a school that really likes it, and I've actually seen it in real projects and I've contributed to it. For example, I was fixing a bug in Argo events, and the way they are doing testing is that was a table driven test, meaning that your test has like multiple criteria and you have expectations and you just like test it in one go. But also you'd find people that say don't do table driven test and have each test kind of like the name is fully clear what exactly it does. But I will opt in for the table driven test here because we have three cases, very similar implementation, so I don't see a need to do it, and this is a very good point to learn. So here's how you do a table test. You define your test, document service, create document with valid parent ID, and you define a table of tests. So you say test cases, which is gonna be a slice of a struct. What would this struct contains? It would contain an argument, and that argument in our case will be a parent ID. So parent ID, which is a string, but also we have, well, what do we want? So should error is a boolean. And now you say, okay, inside my arrays of struct, I'm adding these structs. So here my parent ID is empty, so should error true. Here parent ID is invalid, should error true. Another one is my parent ID is root, should error false, and parent ID we need a valid parent ID, so should error false. But how can we figure out what valid parent ID that would be, right? So this test can cover these three quite comfortably, but now here I want like an exact parent ID that I can use. So the thing that I can do is like I can create like a document and if the error is not, well, fatal error. Now we can say parent ID is document dot ID. And now you have your test cases. So now you just say for each index, for each test case range test cases, here is what we gonna do. What do we want to do? Well, first off, I want to create the service before the loop. So I can say in mem repo error repo dot new in memory repository. So it just returns a repo with no error here. Okay, the in-memory repo now should be used in the document service. So doc service error document service new with repository in mem. Great. All right. Now what? Now we want to document service. So doc service dot create document. Yeah. Yeah, I'll get to that in a second. It's fine. So the create document, what do you want? So the base case has a parent ID, and which document do we want to create? So we created a document up there that we can use. This brings in an interesting thing to my attention that we haven't really thought about as a rule. Can two documents be the parent of the same document? And that would kind of act like a link. So for example, we have one here, it's the parent for two, but we can imagine that like document 3 is also pointing to document 2. I think that's fine. That kind of like implements the whole like synced documents. It's like I have a document, I have a reference to it, I can go and access it and change it. I don't actually have to copy and paste it or like duplicate it to use it somewhere. If that's a rule, it's very easy to implement. We check into the inode table, hey, this document already exists, and we can find its parent, but now we will have to do a depth first search. I'm trying to think if that use case is needed or not. So if I don't, I can pretty much say in the saved document is get the document by parent ID. You add it to that particular parent. And then that document exists on the inode table. The second time you try to add it, it will say, hey, this document already exists. But that wouldn't fully work because now every time you run save document, which will be a lot of times when you're doing updates, there is no way to know if the parent has changed or not without doing search. I honestly think it's fine to include multiple parents. If it runs into issues for us, we'll have to do a bit more computation to search the inode, but guess what? Searching it will be fairly quick. So I'm not really too concerned about that right now. And in fact, this is what's going to happen here, because for each test case, we're saying create the document for that parent ID, which will be root, then that document, and then the second round about, we will say here is this document ID as a parent, and it's pointing back to itself, and that is not good. So here is another test that we need to check. Document should not be able to point to itself. You see, it's a use case we didn't really think about when we're writing the code. It kind of like just appeared, and you better find these now than find them in production. Okay, so here is what we're gonna do. First off, this should return an error. So here, according to our implementation, that should error out. And here is what I can do to solve this problem. So right now, I create a repo. We'll create a parent document. Okay, now I'll add this parent document to the root. All right. So now my repo comes in with this root document and the parent document inside it. So that's great. And now we have this floating document here that we are not really using. So parent ID here, I'd say parent doc.id. This is true. This is actually now false. So I want to move the success cases away from the failure cases. And we can even start with the success cases first, since they are far fewer. So root, parent ID, if it's empty, if it's valid, if it's a duplicated document, so a document cannot point back to itself. And here we go. Now we check if test case dot should error, and error is not nil. T dot fatal. Expected test case to error, but it didn't. Okay, let's check the logic is sound here. So if the test case should error is true and error is not nil. So there is an error that exists, then it should have passed. So here we should say if error is equal to nil. So if it should error and the error is empty, then we are in a bad situation. Then it didn't behave as we wanted to. But if it should error, so it's true, and the error is not nil, meaning there is an error exists, then it behaved as we expect it to be. And if it shouldn't error, if it's false, and the error and the error is equal to nil, meaning that there is false, and the error is equal to nil, so that would be true, meaning that there is no error that happened. So here, let's say this is false, and would error be equal to nil? I don't know why I'm repeating error twice. If the error equal to nil, so when it's equal to nil, this means that there is no error that occurred. So if the error is equal to nil, then that's true, meaning that we're saying it shouldn't error, and yes, we didn't get an error. So that's great, that works. And now if it should error is equal to false, but we have received an error, this will handle it. Okay, so this handles all the 4 cases for us. Now what? So for each test case, we create the document here, and we check for the error, and we handle it appropriately. But now we also need to check the existence in memory repo. So in memory repo, get document by ID, and now we are saying document ID, documented ID. I don't care about the document, but I care error is not nil. 0 error. So the I wonder here if we should have like a type doc, which is documents, and we just create a doc. But we'll have to do it without the new keyword. If I do it this way, now I will be in a bit of a pickled situation here, because I will, it's just a pointer of a strings, actually. It's a slice of strings. Why is it complaining? Give me a sec. It says cannot use type a slice of string, type slash string as type of an ID, right? Okay, that's fine. Now I'm trying to think out loud here. This right here would overwrite our root document that's been happening here. So well, no, sorry. Yeah, never mind. We can't overwrite the root directly, right? This is the parent is the root. This will be added to it. This is good. So now what I'm doing here is that each one would have its own nested document. Okay, but if we do that, what do you mean it's assigned? Oh yeah, sure, add keys, why not? It didn't do what I wanted it to do, but sure, okay. So here the root, we should expect it to have this document, and we should check for the existence of this document. Same here, as we created a parent, we check for it here. Here's an empty situation. We create this, but this will fail, and it says should fail. And the same for like invalid parent ID, it also should fail. And this one here, parent ID now will be different than this one. So what we need to do is copy that ID and we just specify it. So now the same document pointer or IDs in that case, then it should fail. Now this allows us to remove whichever the hell this was. So I don't think we really need any of these here. Well, maybe the parent document. But I most certainly don't need to add it in the repository until we go like all the way down. So here, and let's even see why we need that parent document right here. So here's that parent ID. Should error false. So this is the situation where we have a valid parent ID. Okay. But now this should error, right? Because if you do a parent ID and that parent ID is not already inside the repository, then that should fail. And how can we really test for that? Right? Well, that would be an equivalent of an invalid parent ID. So that's fine. We don't need to duplicate it. But now we'll actually have to go back here in memory repository, and we'll have to redo what we did earlier. So in memory repo, save document to the root with parent doc. All right, but we need some updates here. So doc service create document, parent ID, test case to document. I think it's because we need a pointer, but I'm actually just gonna change it there. So here it will be a pointer, and here it will be ampersand. Great, magnificent. So this part is good. Now in memory repository, get by ID, we need to check that the document that we created, so test case dot doc dot ID, and all of that should be inside a string. Great. Now let's run it. We might run into issues, or it might pass. Let's see. Document with ID 6789 doesn't exist. Right, so here is the bug that we have. Is we're saying it should error, right? And then there is so let me just get back to the 6798 document right here. So this is an invalid situation. So should error is true, right? And an error is not null. So here we got true and did it return an error or not? So if it has returned an error, we would have seen expected test case, right? But this means that it returned false. So that's already an issue in itself. So here's what I want to do is I'll just add, you know what? I'll just print line it. You can use the debugger. We did last time use the debugger. But right now I just want to, this case should error, and I want to see the error. So here it should error is true, and we did get an error. Document with ID doesn't exist, so test case should error is true. Is error equal to nil, meaning that it didn't return an error? Well, false, then we passed successfully. But then we passed successfully, but then we go and we check in the repository. So really, if test case should error, then you continue. Meaning that whenever we encounter an error, then we're not expecting this operation to have succeeded to the repository, so we move forward and we say, okay, we're good now. So we don't need this guy anymore. And bam. And now, let me just like run all the test cases. So all of them pass, but now we can get rid of all these. So this is the first one that we're deleting with a valid parent ID. We've tested for this use case. And this is the second one with root as parent ID. We've tested for this case. With an empty parent ID, we've tested for this use case. And here, a document with the same ID, right? So let's make this false, and let's see. So a good idea is to make your test fail on purpose. So document with ID 10121 doesn't exist. Okay, but it says it doesn't exist. Is that really the correct error? So the create document would go and would say, hey, find that parent ID of one of that number, right? The 1012-1. So it didn't really fail onto the addition. It failed in finding that invalid parent ID. So if we want to test for a duplication for the child being the same as the parent, we already have a parent document. So I can say string parent.doc.id, which we're sure that it does exist. And now that document right here will be the same parent doc, right? So now it will find this doc, and now your test should fail, and that's a use case that we need to fix. So expected test case to error, but it didn't, right? It would be also a good idea that test case, and you specify which test case that is, and the fatal F in that case, and you say the test case. Now if you run it again, you see that you can give them a name, or you can even like get the index. So expected test case 4 to error, but it didn't. So 0, 1, 2, 3, and 4 indeed. Alright, so we've got some implementation to do. So we go to the create document, and here is another validation that needs to happen. So func validate, well actually inside the parent ID, no, that has to be a different test case. So func validate parent is not equal to child, and parent ID, and you pass the child, parent document. I don't like the word parent ID here, to be honest. We should fix it. And same here, right? And the idea here is that is not equal to child. It's a very simple check. parent document can be equal to the child document, and here return no. Okay. Parent validate child is yeah, is not equal to child. I'm not a super fan of the name. So is valid parent ID. And you can say is doc doc unique. All right, let's rerun this test. Look at that. It passed. So, yeah. So we've done a bunch of work with the validation, and we did talk mostly about testing. I was really hoping we can get into the Neo4j aspect of things today, right? But unfortunately, it's getting to be like 9 p.m. It's almost 2 hours in. So maybe next time we can continue with it. Also, we no longer really need the regular create document because we were testing like with the valid parent ID. And since we don't have any other things to test for, I'm just gonna have that as our main create document. And now you're testing behavior of the creation shippo. So that took a bit of time, and we have discovered a bunch of different use cases that we didn't even think about in the beginning in terms of like the document ID and which documents are which. We've also briefly talked about some of the issues with like finding the document from the repo, changing it, and updating it again. And we decided to delegate that to the repo, and this is in particular to like the saved document. So the repo has changed the entity in our memory, and it also saved it to the database. But we haven't actually got to implement the database just yet. Let me commit this code first so you all can have it. I do atomic commits, and I want to finish this use case first and then push it to the main. Right now it's on this branch. So I will add it. I will amend my commit. Actually, let me see. I have it as work in progress. Let me amend that as well. So I added the document service in memory repo. Added create document test. Added create document use case validations, and yeah, that's mostly it. And you get push it. Great. So that's all now available to you on the repo. We will close this branch once we finish the actual repo implementation, and we'll merge it. And then we can move forward to more complex topics. You know what? Let's spend a bit more time. I want to quickly talk about the graph because I think will be very exciting to talk about GraphQL. And I will I'm not even gonna show you Cypher. I will show you Cypher next time. We went into the rabbit hole of testing, but we discovered a bunch of cool stuff. Now, there's many different databases available to us, right? So you've got SQL, which is like a row-based column, right? So you have, oh, I didn't know you can do that, but yeah, so you've got SQL, which is like, you've got like rows and columns, and you have like a schema. So like you can say first name. Let me make this huge. So yeah, you can get something like first name, last name, and maybe age, right? And each of these rows would typically have an ID. So you also have an ID column, which acts as your primary key to accessing this data. Okay, so this is one type of database. This is what a lot of people are mostly familiar with. You write SQL, you're like select like first name from this table, and you can add criteria and selection. This is a great way to put data into categories, especially if you have like a strict definition of where each of these data will work. Sometimes this is a very wonderful thing to do. Then after a while came NoSQL databases, right? And the name as just implies like you don't query it with SQL in the traditional sense, and they're also not a row-based documents. Mind you that if you actually read a bit, if you actually read a bit about the history of databases, you'll find that there is a lot of these ideas have been repurposed or like have been seen before, but the implementation wasn't there for one reason or another. So, for example, there was object databases that got trends for a while and then it kind of like died off. There was other NoSQL databases way before Mongo, way before Node.js popularized like document databases, and it also died. But right now we've seen like MongoDB, we've seen a bunch of like NoSQL that have been quite successful. So we talked about SQL, and now we can talk about NoSQL. And the idea of NoSQL is like typically it doesn't have a schema, meaning that you don't define the shape on the database, so you don't add these enforcement into the database. Sometimes you can, some databases do offer that, but it is meant for the flexibility of changing the document format. It's very useful when you're doing prototyping or you're exploring or updating your definition or like your information quite constantly. So it really works with that quite well. And the idea is like, the way I personally like to think about it is like it's a big JSON object that you say first name, right? Last name, age. But then later on you can go and you can add more information. And the idea is the database is not gonna complain about these for you. Versus in SQL, if you add more columns, you might have to do some modifications on each row, and you have to update the schema and make sure like if you don't have the value, then what's the default value will be. Versus here, your schema is really happening on your code. So if you've read data intensive Yeah, so if you read this book, designing data intensive applications, right? He talks about this concept of like a schema on read versus a schema on write. SQL is a schema on write. So like when you're trying to write something, the database is handling the schema for you. Is like, hey, this is valid or not. Versus a Mongo or NoSQL, typically, you are saying, here's the data. The database is like, oh, okay, that's cool. And then when you're reading it, you have to specify how you read it and how you interpret this data. Now, we moved a bit forward as well and came the concept of graph databases. And I believe it got popularized by Facebook because they were like one of the first that at least that made this extremely popular, where they used the graph database and the scale of Facebook. And the idea is like you wanted to create relationships between people and be able to analyze who's friends with who and where's the mutual friends and these mutual friends, who's their family and how these families relate back to you, and knowing pretty much everything, including your own underwear color. You know, Facebook knows it all, so Big Brother is always watching, and that could be powered by graph databases. And the concept is quite simple. If you study data structures, right, there's the concept of a graph, which is a bunch of nodes and bunch of relationships. That's not an arrow. So here, here, and here, right? But you can also have relationships between nodes like that. So for example, this could be me. You all are my friends, but you could also be friends that know each other without my relationship with you at all. But in a graph, you can simply infer these things quite easily. So here you have a node. This node has a type. So this is a node. And this is a relationship. I don't even know if I spelled that right, but sure. Typically, nodes have label, meaning that this could be a person. Right, so here's a person, here's a person, here's a person, and here's another person. And these nodes, of course, they don't always have to be the same type, and that's the beauty. Because here, for example, we can all be like going to a location, right? And with these relationships, let me just show you something here. So let's take these relationships for a second. So here we can say friends with so there's friends with, friends with, friends with, friends with, but here check in. So the thing that I want you to take away from this, I promise I'll do my best next time to be able to actually like show you Neo4j and all the graphs. I actually had a bunch that is like prepped for you, right? Just so you see here, I actually had all of these prepped just for you, right? And this actually has to do with like our own implementation of documents where a person has the root document and the root document has nested root documents, right? But I want to conceptually show you what the graph is. So you've got a bunch of people. These people are friends with each other, but you can also see relationships between this person and location. This opens a whole realm of possibilities because you can analyze your data in a extremely unique ways. So you can see, for example, if Omar checked in this location and another person checked in this location and he's also friends with him, then they might be like hanging out, right? Or if they're not, you can introduce a friends nearby service and you can link them together. So the possibilities are endless here. In our domain, where we have documents and nested documents and segments, each we will have a user, right? And that user will have a bunch of documents, but all of these documents are stemming from the root document. And this is just a doc, and a doc. Great. So here, user, root doc, bam, bam, and bam. You see here? So now each of these documents can have other documents. So in our database, we're modeling it as a graph, but when we're using it in our application, it's just an inode. And now we went a full circle. Why do we need to use a document data, a graph database over a document database? Because literally the word document is like in document database. Well, we are nesting a lot of documents together, and each of these documents would have objects, and these objects, which we call segments, will have different behavior. A lot of these might be shared between other documents, like if you want to do sync blocks in Notion, or if you want to share it with a friend to do collaborative editing, and you're only sharing this one particular document. In a graph database, this is so much easier to do than it is to do with a regular documents database. Because if you're doing it with a regular document database, you need to figure out how to link these IDs together, and you have to do like a bunch of nested queries, and you have to deal with a lot of JSON. Versus here, your conceptual model of your data could be translated into the graph, which is super awesome, right? Next time, guys, we'll be talking about Neo4j, we'll be talking about Cypher, we'll talk about more about what these directions and the relationship means. We'll discuss labels, properties, and so much more. So tune in, and I look to see you in the next stream. Thank you very much, and good night.